Hello everyone. In the previous class we read about derivatives as the rate of change. Now we are going to read about the increasing and decreasing functions. This is a very basic thing. Y is equal to fx is a function. Alright. Now the domain is x, the codomain is y. Now if you go on increasing your x, you get y is also increasing, continuously increasing. In that case your function is increasing function. And if you go on increasing the x but y goes on decreasing, subsequently you see that there is a decrement in y. In that case it's a decreasing function. So we will discuss this with an example. Let's take a very common function, x square. Alright. So you know, if x is raised to any even power, say x square, x to the power 4, x to the power 6 and so on, you get a parabolic curve, right, like this. So now you see, we will take different values of x. If I take x as -3, -3 ka square is 9, right, -2 it's 4, -1 it's 1, 0 gives you 0, 1 gives you 1, 2 gives you 4 and you say 3 gives you 9. Alright, now just see one thing here. When your x is smaller than 0, when x is smaller than 0, that means we are talking about this domain. You see, when you're going on increasing your x, your y goes on decreasing, है ना? -3 से -2, -2 से -1 पे आए, आपने x की वैल्यू को इंक्रीज किया, x is going on increasing but your y is going on decreasing. The value drops from 9 to 4 and then drops from 4 to 1. So you see, for the domain x smaller than 0, you get your function is decreasing. Alright, fx is decreasing. But at the same time, when you see x greater than 0, you go on increasing the x. With increment in x, you see your y is subsequently increasing. Alright, so that results in the increasing function. For the domain x greater than 0, fx is increasing. Alright, so this is the major difference. You see the graph here. अब देखो यहाँ पे ग्राफ x smaller than 0 domain की बात करते हैं हम. This part of the graph, you see the graph is going downwards. Downfall is there. But as you cross 0, means as you come to the positive domain, you see that the graph goes on rising. यहाँ पे ग्राफ की हाइट बढ़ रही है पर यहाँ पे ग्राफ की हाइट डिक्रीज हो रही है. तो दैट मीन्स ऑन x smaller than 0 ये फंक्शन इज decreasing and on x greater than 0 function is increasing. And you see the function is defined on whole real number. X is defined for all the real numbers. There is no breakage, right? Now this takes you to the proper definition of increasing and decreasing functions. Let I be an open interval contained in the domain of a real valued function. Real valued function means there is no imaginary number, or you're only going to get the real values for all the x. So the function is a real valued function. अब वो मतलब कि पूरे r पे डिफाइंड है. अब उसके r की कुछ सब इंटरवल्स हम लेंगे, सब इंटरवल्स और सब डोमेन्स जिन पे वो फंक्शन डिफाइंड है. इन डोमेन्स को हम लेंगे, डिनोट करेंगे i से. जैसे कि आपका x स्क्वायर का जो केस था, उसमें एक इंटरवल आपका -∞ to 0, एक इंटरवल आपका 0 to ∞. यहाँ पे फंक्शन की ग्रोथ में चेंज आ रहा था, ठीक है. तो -∞ to 0 एक इंटरवल 0 to ∞. अब इन इंटरवल्स पे एक फंक्शन इंक्रीजिंग और डिक्रीजिंग तब कहलाता है जब इंक्रीजिंग ऑन i इफ फॉर ऑल x1 x2 बिलोंगिंग टू i, इस इंटरवल के बीच में कोई भी x1 x2 लें एंड x1 इज स्मॉलर देन x2 implies fx1 is smaller than or equal to fx2. Note this symbol, smaller than or equal to fx2. That case your function is increasing. Decreasing on I, when if for all x1 x2 belonging to I you have x1 smaller than x2, implies fx1 is greater than fx2. यहाँ पे देखो आप वही चीज़ हुई थी, अगर ये 1 है और अगर ये 2 है तो 1 पे वैल्यू 1 होगी, 2 पे वैल्यू 4 होगी, ठीक है। आपने x को बढ़ाया तो आपके एफ एक्स की वैल्यू भी बढ़ती चली गई, बट इन द डिक्रीजिंग फंक्शन आपका इंटरवल -∞ to 0 है। यहाँ पे आप जैसे जैसे x को बढ़ा रहे हो, x को बढ़ाते जा रहे हो तो फंक्शन की वैल्यू डिक्रीज होती जा रही है। सो दिस इज योर डिक्रीजिंग फंक्शन। द की नोट हेयर इज दिस सिंपल, look at the graphs A and B. Although you can tell me that both of them are increasing functions, but there is a slight difference in both of them, right? You are getting this. Both of them are increasing. You go on increasing the x, ग्राफ की हाइट बढ़ती जा रही है। Here also x को बढ़ाओ तो y की भी वैल्यू बढ़ रही है। ग्राफ में कहीं पे भी डाउनफॉल नहीं है, पर देर इज अ डिफरेंस। Here you see this is an increasing function, ठीक है। You can imply that this is an increasing function. For x1 smaller than x2 you get f of x1 either smaller than or equal to f of x2, right? But here it's a smooth curve, so this is where the difference lies between increasing and strictly increasing function. For an strictly increasing function, f of x1 is strictly smaller than f of x2. The possibility of x1 getting equal to f of x2 drops out. fx1 is smaller than fx2. This is your strictly increasing. This is your just an increasing function, right? Now similarly you see that your graph C and graph D both are decreasing. Yes, you see height is going on decreasing. Here also the graph has a downfall, complete downfall. Both of them are decreasing, but here you see this is not a continuous graph. Here there is a possibility if x1 is smaller than x2 you may get f of x1 greater than or equal to fx2, right? This is simply decreasing function. But here you have gotten a smooth curve. There is no breakage, no edge, a smooth curve that goes on decreasing, and the possibility of fx1 getting equal to fx2 drops out. This is your strictly decreasing function. If x1 is smaller than x2, f of x1 will be greater than, strictly greater than f of x2. Alright, so this is the major difference between increasing, strictly increasing, and increasing, strictly decreasing and decreasing. This is decreasing. Alright, so there is a difference in the graph also. strictly decreasing होगा या strictly increasing होगा तो smooth curve होगा। अगर ऑल्दो यहाँ पे इन ग्राफ्स में देखो बढ़ता ही जा रहा है, कहीं पे भी डाउनफॉल नहीं आया है, पर एजेस हैं, मतलब डिसकंटिन्यूटी है एक तरीके की ग्राफ में, वो आपका इंक्रीजिंग फंक्शन तो है बट स्ट्रिक्टली इंक्रीजिंग नहीं है। ऑलराइट, अब आप एक और तरीके का ग्राफ देखो। ये आपको समझ में आ गया? इसको आप कहीं पे यू जस्ट डॉट इट डाउन एनीवेयर। नाउ जस्ट लुक एट दिस ग्राफ, समथिंग लाइक दिस, राइट? अब दिस ग्राफ इज डिफाइंड ऑन इंटायर रियल नंबर लाइन, रियल लाइन पे डिफाइंड है। नाउ ऑल्दो दिस ग्राफ इज इंक्रीजिंग ऑन सम इंटरवल एंड डिक्रीजिंग ऑन सम इंटरवल, जैसे कि आप देखो इस पॉइंट से लेके इस पॉइंट तक दिस ग्राफ इज गोइंग ऑन इंक्रीजिंग, फ्रॉम दिस पॉइंट टू दिस वेरी पॉइंट यू सी दैट देयर इज अ डाउनफॉल इन द ग्राफ, बट overall on the domain R this function is neither increasing nor decreasing. All right, whereas if I just talk about this domain, this means part of the domain, you will see that the function is decreasing. And if I talk about suppose this domain, you see on this part of the domain your function is increasing, but overall as a whole this function is neither increasing nor decreasing. So these are the major difference between strictly increasing, strictly decreasing, increasing and decreasing functions. Now let us just go through everything that we have read. increasing on I is the interval on the domain on which this fx is defined, right? So increasing on I, the function is increasing function when fx1 is smaller than or equal to fx2 for all x1 is smaller than x2. Strictly increasing means if x1 is smaller than x2, this implies fx1 is strictly smaller than fx2, means this inequality is dropped out. Now decreasing on I, if x1 is smaller than x2, this implies fx1 is greater than or equal to fx2. And for strictly decreasing on I interval, if x1 is smaller than x2, this implies fx1 is strictly greater than fx2. Alright. So this is all about increasing and decreasing function. Now we will connect this with the derivatives, because after all we are going to read about the applications of derivative only. So let's see. See, now comes the theorem. Let f be a continuous function on the closed interval a comma b and differentiable on the open interval a comma b. Then f is strictly increasing on a comma b open interval if the derivative of the function is greater than 0. Now you see where derivatives come into play. When the derivative is greater than 0, simply the function is strictly increasing for that interval, yes. And if the derivative is less than 0, then the function is strictly decreasing on that interval. That's it. अब देखो यहाँ पे एक डिफरेंस है. अभी हम एक पूरे डोमेन के एक इंटरवल की बात कर रहे हैं, राइट? x बिलोंग्स टू एनी ओपन इंटरवल a कॉमा b. दिस इंटरवल कम्स फ्रॉम द डोमेन ऑफ द फंक्शन, मतलब fx इस डोमेन पर डिफाइंड है, उसका एक हम छोटा सा पार्ट ले रहे हैं, a कॉमा b ओपन इंटरवल. पर अगर आप देखो कि पूरे डोमेन पे अगर f dash x is greater than 0, in that case you just simply say that the function is increasing function. Or similarly, see when we are talking about strictly decreasing function, strictly decreasing, तब हम एक छोटे से इंटरवल की बात कर रहे हैं. अगर हम पूरे डोमेन की बात करें और वहाँ पे अगर हमें मिलता है f dash x is smaller than 0, in that case we will simply say fx is a decreasing function. Overall, this is how we bring into play the applicability of derivatives. कहाँ पे f dash x is used, मतलब derivative अब यहाँ पे use हो रहा है. Alright, so this is all that is going to be required in the entire topic. Now we will solve some questions and see what kinds of questions are framed. Okay, fx is 7x plus 13 and you are asked to assess whether the function is increasing on the real number, strictly increasing on the real number, decreasing or strictly decreasing. Now first we will do this by the principle of increasing and decreasing function. So if you have x1 smaller than x2, alright, suppose first of all let x1 and x2 belong to your interval, any interval, right? यहाँ पे तो रियल नंबर की बात हो रही है तो हम रियल नंबर ले लेते हैं. So if x1 is smaller than x2, alright, so that means 7x1 is also smaller than 7x2. No change in inequality. Now if we add 13 both the sides, still there will be no change in inequality. Plus 13, what you got? fx1 is strictly smaller than fx2, right? So what does this give you? This gives you that your function is strictly decreasing, no, increasing, sorry, strictly increasing, right? Strictly increasing on R. We started from x1 is smaller than x2. We have implied that fx1 is also smaller than fx2. That means the function is strictly increasing on R. Alright. Now by the derivative thing also we will try to do. If fx is your 7x plus 3 plus 13, right? So your f dash x is what? 7, which is greater than 0, right? That means your function is strictly increasing. Look at this question. Fx is equal to x cube minus 3x square plus 4x. Alright, and x belongs to real number. So obviously you are going to find the derivative of this function. Your f dash x is 3x square minus 6x plus 4, right? Now you have to check whether this is greater than 0 or smaller than 0. From here you are not getting anything, कुछ भी नहीं समझ में आ रहा है. So you see 3x square minus 6x plus 3 plus 1. Now you can take 3 common, you get x square minus 2x, right, plus 1 plus 1. अब देखो ये मिल गया आपको 3 into x minus 1 का whole square plus 1. Alright, f dash x. अब 1 is a positive number, 3 is a positive number. This whole term is going to be positive because it is a square number. Positive into positive plus positive, right? So overall it's going to be greater than 0. That means your function is strictly increasing. Right? Next question. Find the intervals in which the function 2x cube minus 3x square minus 36x plus 7 is strictly increasing, strictly decreasing. Alright, so you know, first of all you will find the derivative of this function, right? And then you will see whether it is greater than 0 or smaller than 0. So derivative of the function is 6x square minus 6x minus 36, right? So from here you cannot tell whether it is greater than 0 or smaller than 0. You have to factorize it. Let's do that. Take 6 common, you get x square minus x minus 6, right? So 3 2 just 6, right? Minus 3 plus 2. X square minus 3x plus 2x minus 6. So you get x minus 3 plus 2x minus 3. Alright. Overall your factors are 6, x minus 3, x plus 2. Right? This is your f dash x. Now find the critical points first of all. Put this as equal to 0, 6 x minus 3 and x plus 2 is equal to 0. So you get x is your 3 or x is your 2. Right? Minus 2, minus 2. Critical points are 3 and minus 2. Alright. So draw the number line. Minus 2 or 3. Right? So there are 3 intervals here. Minus infinity to minus 2, minus 2 to 3 and 3 to plus infinity. Right? Now you will separately check the this increasing or decreasing, plus minus plus, right? When you find the sub intervals तब आप plus minus plus कर दो and f dash x is greater than 0 for all the positive intervals and f dash x will be smaller than 0 for the negative interval. मतलब positive होगा आपका माइनस इन्फिनिटी से माइनस 2 पे, मतलब यहाँ पे इंक्रीजिंग है, और 3 से इन्फिनिटी पे इंक्रीजिंग है, और डिक्रीजिंग होगा आपका माइनस 2 से 3 पे. ठीक, ये तो एक तरीका है, बट तो आप इसको स्टेप वाइज स्टेप सॉल्व करना. सी हाउ. फॉर द इंटरवल माइनस इन्फिनिटी टू माइनस 2, ऑलराइट, आप यहाँ से टेक एनी नंबर फ्रॉम दिस इंटरवल, एनी एक्स फ्रॉम दिस इंटरवल एंड पुट इट इन द दिस एफ डैश एक्स. यू विल गेट दिस टर्म विल कम एज दिस इज 6 पॉजिटिव ओनली. माइनस 3 लेके देख लो, बीच में माइनस 3 आएगा, माइनस 3 ले लो, ये नेगेटिव, माइनस 3 से दिस विल ऑल्सो गेट नेगेटिव. ओवरऑल दिस इज पॉजिटिव, मीन्स increasing. f dash x is positive, greater than 0, that means the function is increasing, right? minus 2 से 3 ले लो. यहाँ पे take any x. For an instance I will take 1. For 1 you will get this as minus, ये तो 6 is plus only, this will be minus, this will be plus, so this is overall minus. f dash x is smaller than 0, that means decreasing. Alright, similarly for 3 and 3 to infinity, take any number, means any positive number. greater than 3. This is also positive, this is also positive, this is also positive. Overall it's positive. That means f dash x is greater than 0. The function is increasing. So as your answer you will get the function is increasing on the interval minus infinity to minus 2 and on the interval 3 to infinity, and the function is decreasing on the interval minus 2 to 3. Alright, अब इसको आप अपने हिसाब से अच्छे से प्रॉपरली लिखना. दिस इज हाउ you have to do these kinds of questions. First of all, find the derivative and then do this.